All right, good evening, everyone. So let's now talk about your written test one on Wednesday. Why don't we take a quick look on the test guide just for a few minutes, just to make sure you don't miss any important information. So I presume you have read it. It's really important, but I'm gonna highlight certain parts very quickly. But of course, you gotta make sure you read through the guide. The time constraint will be the same as your programming test. You'll be given 15 minutes. The only difference is now you are not allowed to use any rodent during the test. So you will be using E-class, multiple choice, or maybe some textual answer you have to type on the keyboard. So that'll be the format. But if you try to practice test, you will get an idea. So you must go to your enroll session there for your test, and you must be in person in the lab. Okay, so the time is just as before, so there'll be no surprise. And then, so please make sure your EECS login is working to log into the lab machine. And also, you're gonna need your Passport York account to log into eClass. So there will be two quizzes for you to complete on the day. So one quiz will be the pre-test on academic honesty. That's like a formality. So you want to complete it. And then once you completed that, you will be able to start your actual written test in time. So that'll be another test. But you'll be clear once you get to log into the machine. All right. And then make sure you also bring your ID. So we're going to do attendance check. That one should be clear. And it's going to be closed book. And you can feel free to bring your own sketch paper if you find the need. We're not going to provide a sketch paper, but if you bring your own, please make sure it's blank on both sides. All right. So the formats, right? It could be true, false. It could be single correct or multiple correct, right? And that's the E-class policy about how to grade, right? That's something you might be familiar already. And so there might be some question there that you have to enter maybe some mathematical construct in rodent syntax. And given that you have already studied for your programming test one, so writing ASCII syntax should not be a problem. The only difference is you will not be provided any event B summary PDF this time. However, I would say all the construct you might be required to write during the test, they are only from the review math lecture. There's nothing that's outside of the math lecture you have to know, right? So just make sure you understand the basic relational operators, set operators, partial function, total function, etc. How to write those symbols, restriction, subtraction, things like that. It's not that many you have to remember, right? So I just gave you some example over here about the mathematical construct. You will have to know how to write them in the rodent syntax. You can take this as a starting point over here, right? This section here. And then the review on math lecture there will be the main slides for you to study. You don't have to study anything that we just started on the bridge controller, which we just started on Thursday before the reading week, and we're gonna continue that on Tuesday. But you don't need to worry about that for this written test. Also, you don't need to worry about lab number 3, right? That's something you are still doing, but you don't need to worry for the written test. And also, you have to make sure you also understand the mathematical construct sets relations for lab 1 and lab 2, right? Lab 1 and lab 2, you already studied them for programming tests, but now the more focus will be more on the understanding of the mathematical construct, right? For example, if I change the relation a bit, maybe from relation into function or from function to relation, so what should be the consequence, right? So those will be testing your understanding. And the example question is already on the e-class. I posted them Monday last week. And then I think today we can possibly start the review session by going over those questions there. Okay. We can go over all of them. Hopefully it wouldn't take too long. And then we'll see how much time remains. And then whatever time remains, you can ask me more questions, maybe about the mathematical review lecture. That could be the plan. All right. Guys, do you have any question for me first to start with? Anything you want to ask me before I start the practice test question? I think that could be a good starting point before you ask me other questions. Anyone? All right. If no, and I may just continue. All right, with the practice test. All right. But anytime, if you want to ask any relevant follow-up, I would suggest just interrupt me. So we don't really have to wait until the end for you to ask new questions. Okay, let's go one by one. All right. All right, so question number 1 for the practice test. Okay, so this one here, let's read the question together. We're going to consider this predicate here. Of course, in a written test, you might be given predicates in either the rodent syntax or in the mathematical syntax. So what you can do is on your sketch paper, you can try to translate this predicate over here in rodent into the paper form right away, right? Apparently, this is a universal quantification. So it would be for every x, y, bullet point, and then the range will be x should be a natural number, and also y is a natural number, and then it is the case that x multiplied by y larger than 0. If you're already pretty comfortable with reading math in the rodent format or ASCII format, you don't really have to do this transformation. For example, for myself, I feel a little bit more comfortable reading in this format, but you can make a choice. Okay, or maybe if I give you this form over here, sometimes I might ask you to write the answer maybe in the rodent syntax, right? So that's why you want to be very smooth in transitioning between the two syntax. All right, we're going to consider these answers in isolation, and then we're going to see which one will be correct. All right. So now what we're going to see is we're going to see each one of them, right? But we can try to maybe judge right away to see if this here is actually a theorem or is that correct, right? So it's a universal quantification. That means everything that's in this range, all the combination of x and y, it should be the case that x multiplied by y larger than 0. Is that the case, right? That's something we want to decide. Anybody would want to say, should this be, before we even consider the answer, you want to have some good intuition. Should that be true or false? First of all.
False.
False.
False. Okay. Okay, I agree. Okay. That's good. Okay. It turns out it's false. Apparently, for example, you can see if x is 0, which is a natural number, and y is 5, which is a natural number, but 0 times 5 is 0. Larger than 0, apparently that's false, right? Maybe that's what you're thinking. But let's not consider the answer. I think the answer can kind of nicely review the proof strategies that we spoke about in the class. Let's look at them carefully. So number one, the predicate is not a theorem. I think this part is good. And it can be disproved by a pair 5, 0. Okay, this one actually looks good. I can tell you why. So now what we need to look at is the body of the universal quantification. And if we want to disprove the universal quantification, we need a witness, right? So the witness, the question is suggesting is 5, 0. So what you're going to do is you're going to do this. 5, a natural number, and 0, natural number. In the actual test, you don't really need to write it down. Just write in a way that can help you answer the question. But for now, just for explanation purpose, I'm going to write it down. That one implies 5 multiplied by 0 larger than 0. So apparently, this part over here is true. Both of them are natural number. And this one here is actually false because 0 larger than 0 is false. So if you recall the truth table, true implies false is the only case you can give false for implication. So this is a good and appropriate witness for violation. Okay, so this one should be chosen. If the answer is like a radio button, like only one answer, I think you're done. You should be confident enough to say, okay, that should be the answer. But since we got we got boxes over here, so you got to consider every one of them. Okay, let's now look at the second one. It is not a theorem. Okay, this part over here also is good. And it can be disproved by 12, 13. All right. So this one is not appropriate because you want to know whether or not this is a good witness. Let's put a question mark over here. So we can try 12 is a natural number, and also 13 is a natural number, implies 12 multiplied by 13 larger than 0. Apparently, again, this one here is true. But this one here is also true. So if you recall, true implies true is equivalent to true. So this is not appropriate witness. So you can think about the first part of the sentence over here is correct. But however, to claim that this pair 12, 13 can be a disproved witness is wrong. So this should not be chosen. All right. So hopefully that's okay by you. Let's now look at the next one. Okay. And we got it is a theorem, right? This is already not correct. So you can right away reject it. Okay. And then not a theorem, the next one. And then we got 12 minus 2. All right. How about this one here? This one is similar to choice number 2. It's also inappropriate, but in a slightly different way. Let's now take a look. Okay. So now for this one here, you will, again, we want to judge to see whether it's a good witness to disprove that predicates. So 12 natural number and also minus 2 natural number implies 12 multiplied by minus 2 larger than 0. Okay. And this one here apparently would be false because you see minus 2 cannot be a natural number, right? Only starting from 0. So that's false. And we know that false implies anything is called the zero of implication is equivalent to true, right? So you can see so far we also review 3 different rows in the implication. Well, actually, we review all the 4 because now false is simply on the left-hand side, right? So this predicate here is going to evaluate to just true. So this implication here is just going to evaluate to true. So this witness also is not appropriate to disprove. All right. So we also cannot choose number 4. And number 5, apparently it cannot be chosen because we know that at least number 1 is actually correct, right? Okay, finally, we also say it is a theorem. That's also something we can reject right away. Okay. All right, so the final answer should be only option number 1. Okay, so that should be the correct answer. That it will be chosen. Okay. So what do we learn from this question here? I would say several things. Number 1, you want to make sure you understand the truth table for the implication, right? So we just reviewed them already. And also you want to understand very well the proof strategy for universal quantification. I believe the next question there is about existential, which we're going to see as well. But of course, when you review, you want to use the question itself to tell you which topic you should really take a look more deeply, not just the question itself. Okay. All right, guys, any follow-up to this question here that I can answer? Feel free. All right, if no, let's now move on. All right, the second one. And the second one is about existential quantification, right? So let me just turn that into the math form right away. So this one here would be there exists x, y, bullet point. The range will be x is a natural number, and also y is a natural number, and also x multiplied by y larger than 0. All right. Again, if you feel very comfortable about reading ASCII format for the predicate, you don't need to convert that into math form, right? But this one also looks nice. Okay, why don't we take a look at this? And I think for this one here, it should be a theorem, right? Because in order to prove existential quantification, if you review the proof strategy, we only need to show one witness, right? But to really disprove it, you will actually need to argue for all the combinations, right? So just a quick review. So to prove existential quantification, need one witness. On the other hand, to disprove it, it will be the harder case. You will need to consider all the combinations. And for the details, you can definitely refer back to the lecture materials. We spoke about them in detail back in the lecture. Okay. Let's now consider the answer. Okay. So let's see option number 1. It is not a theorem. By the way, that can be rejected right away, right? Because, for example, if we choose 5 and 3, 5 times 3 will be larger than 0. That's for sure, right? So whenever we see not a theorem, we can reject them right away. All right. And not a theorem over here. Also, we can reject them right away. However, I would like to talk about maybe option 1 and 2 together, just to for our interest. I think there's something that might be could be potentially confusing, but let's clarify that 100%. You might be saying, so here 50 over here, 5 times 0 is actually equal to 0, and 0 larger than 0 is actually false. And, okay, let me make it more precise. Let me write it down here. Okay, I can talk about just this one here. And the argument for choice number 2 will be the same. But my point is, if you're confident that this predicate here should not be a theorem, sorry, let me say it again. Since we know this predicate should be a theorem, we can prove it easily, for example, phi 3. If you know that that's the case, whenever you see any choice where it claims that it is not a theorem, you can reject it right away. But I would say for our learning purpose, let's also consider the second part here, okay? Just to make sure we really understand why that part should also be rejected, okay? And let's now talk about the 50. If I plug in the numbers, it would be that there exists xy, right? And here, oh, I don't need this part here. I can just plug in directly 50 into this part here. That's what I'm going to do. Okay, so let's try 5 natural number and 0 is natural number, and 5 multiplied by 0 is larger than 0. Apparently, this part here is true. And this part over here is also true. And this part here is actually false, right? So the whole thing over here is false. So hopefully you're not confused. You might be thinking, well, if this is actually a witness that can show that the existential quantification may be false, in that way, wouldn't this be a witness to disprove it? You might be confused. Hopefully you're not confused by that. But if you are, you want to be very clear when you study the proof strategy. Whenever you want to show that the existential quantification is actually not a theorem, you cannot just disprove it by a single witness. As we said over here, to disprove, you have to consider all the combinations. Just using a single witness is not the way to really disprove an existential quantification. You can only use a single witness to prove existential quantification, right? So that's important for you to realize. Okay. So what I would say is, for the star over here, is witness evaluates to false, but not sufficient to disprove existential quantification. All right, that's something I would like to say. And you can have a similar argument for choice number 2. I'll leave that to you. All right, so we can ignore number 3 just for now. Of course, if all the other options except for 3 are incorrect, of course, we're going to choose option 3. But let's see. What about option 4? It is a theorem. Okay, this part here match our prediction, well, have our judgment here. But can it be proved by -2, -3? All right, so this one is interesting. Okay, let's take a look. This one here, -2, -3, -2 multiplied by -3 will be 6. 6 larger than 0. So that's 6 larger than 0. That's true. So should that be true? Be careful. It's a little bit tricky because when you evaluate it, you have to evaluate the entire thing over here. All right. So it turns out you got to evaluate -2 natural number and -3 natural number, and also -2 multiplied by -3 larger than 0. And apparently, these two are both false. So that means the conjunction here is going to be false. Doesn't matter what this is, even though it's true. All right. So this can be proved is actually wrong because evaluate to false. All right. Okay, what about number 5? Well, number 5 here, so we got 5, 4. All right, that looks a bit more promising, but let's give it a try. 5 natural number and also 4 natural number and also 5 times 4 larger than 0. This is true. This is true. Also, this is also true, right? So the result is going to be true. All right, that should be straightforward. So number 5 should be chosen. It's a theorem, and then we only need a single witness. And as we just showed to you, this is a valid witness. Number 6 can be argued the same way. So it's a theorem, yes. And now what about 2, 3? Well, that's something I can let you do, right? 2 is a natural number. 3 is a natural number. 2 times 3 larger than 0, so it's also going to be true, right? So that can also be a witness to prove existential quantification. So number 6 should also be chosen. And number 7, we already rejected that. It's not a theorem. Just that part is actually wrong. All right, so the final answer should be 5 and 6. And apparently there's some right answer, so number 3 should not be chosen either. All right. All right, any question here about this question? Any follow-up you want to ask? All right. If no, I presume everybody is good, in which case I'm going to move on. All right. Okay. All right, what about this one here? I would say these two are kind of irrelevant to each other. It just tells you that you should know how to really prove or disprove the logical quantification, right? And let's now move on. So this one here is more about set operator. And this one here, I think I somehow split the expression here that's required by the answer into a little bit like several chunks for you. They're just a little bit easier. So eventually we want to calculate cardinality of something. So the cardinality of the power set of something here. And then it's this particular set. And the set itself is computed by, let's see here. So it's going to be, first of all, the difference between A, B, C, D. You know what? Let me write, I just need more space. Let me write it again. So again, we need a cardinality of something and the power set. Once we compute a power set, we can take its cardinality. And then here we got set difference to be computed first, because you can see the parenthesis, right? As you can see, there is a parenthesis telling you the set difference should be done first, right? So we got A, B, C, D. Set difference A, E. And do it first, and then after that, you're going to have union, right? I'm just going to put union here, and then AF. Okay? Yeah, so that's basically what we're computing. And I would say you can go kind of go with the order. We definitely want to calculate this set expression first. Once we know what this set can be simplified into, we can calculate its power set. And once we know its power set, we can calculate its cardinality. But here, to really figure out the cardinality of the power set, you don't necessarily have to numerate the power set out. You don't have to. We kind of show you how you can do it in the class, right? That's something I can review briefly, but actually by using this question here. But you should definitely also review what we said in the class. But if I didn't say cardinality over here, in that way, I just want you to enumerate the power set. That would be a different question, of course, right? But we also talk about it in the lecture. All right, let's now do one by one. What about this one here? This is the set difference. We're going to find out a set, basically anything. We want to find out everything that's in here, but not in here, right? That's the difference for set difference. So you can see the only thing that's both in here and here is the A only. E only exists in the second set. So having the set difference has no effects on the left side, the left set over here. So we're only going to remove A, right? So we got B, C, and D left, right? So I would say union intersections are very straightforward. So maybe you really want to have the set operator like a set difference and other relational operators and I mean the relational operator on the relations on the function those operator like an example we did in the class. You want to review them. All right. And then we're going to say union with AF, right? And that one there is going to give us a set A, B, C, D, F. All right. And then we're going to take its power set, and then we're going to take its cardinality, basically, right? So that's what the question boils down into. All right. So as I said, if you don't really have the cardinality over here, then you will have to calculate exactly the power set. That could be the case, right? If I ask you, maybe I wouldn't ask you to enumerate everything. I might say enumerate the subsets of size 2 or size 3, for example, or give me only the minimum subset, or give me only the maximum member in the power set, right? So that's all the possible question I can ask. But let's focus on this one. We're going to get a cardinality, right? And according to what we said in the class, so here, if you want to calculate cardinality of the power set, you can think about for each element here, 1, 2, 3, 4, 5, we have a binary choice to really include it or not to include it, right? So it will be 2 to the power of the cardinality of A, B, C, D, F, which will be 2 to the power of 5, right? Which will be 32. Right? So that's the answer. All right. Any question on this? So the practice question there, as I said, they're only for you to really get an idea about the formats, about the multiple choice, or about the textual input you may have to enter. Of course, from there, you should really go back to the lecture and make sure you study all the relevant topics, right? It will be a wrong expectation to say the practice test is going to cover everything you're supposed to know for the written test. Okay. All right. Any follow up would you like to ask? Anyone? All right. Hopefully, so far, still straightforward for you. All right. Let's now move on to the next one. All right. The next one there, we got a logical quantification, and you can see that's a universal quantification. And
Professor?
question. Okay. Go ahead, please.
Oh no, somebody I think said something and has a question in the chat.
Oh, in the chat. Let's take a look. Give me just one moment. If there was no parenthesis, what would be the order of the operator? Okay, I see. It's a good question there. Okay, good. A, B, C, D. You're saying if there is no AF. Yeah, so that's really to do with the precedence of the set operators, which we didn't really talk about in the class. So I would say for the purpose of the written test, I will make sure I bracket them, properly so you would know explicitly about the order of evaluation. But that's something I can look up for you. I don't quite remember the exact precedence, but I believe all the binary operators on the set has the same precedence. But when you actually want to evaluate, it's going to be left associative, which means you're going to evaluate this one first, and then you're going to evaluate that. Okay. But that's something I will need to check for you. But for now, for the test, you don't need to worry. I will make sure I bracket them whenever necessary. Okay. So this one, I believe, will be as if you try to do the leftmost, and then after you get a result, it's going to be this one here. But I will need to double check. All right. Okay, I hope I answered that question in the chat. All right. All right, let's now move on to the next one. So this one is about rewriting the predicates. So we are rewriting basically universal into another, the other logical quantification, right? We do have a rule in the slides. So let me write down the rule over here. If you say for every some variable list, some range implies some property that will be equivalent to, I think we even did a little bit proof in the class. So you'd be not the case, exist, and range remain the same, and not px. All right. So that's something also can be found on your slides. So we're going to just do that. Okay. So let me just, for completeness, let me just copy this quickly. Okay. And then we'll see how to just negate the property part. So here we got for every xy dot x a member of natural number and y a member of natural number implies x plus y larger than or equal to 10 and x plus y less than 20, right? You can think about this part over here is really the property, right? It's like a p of xy, basically, right? And you can think about this part over here is the range as the range of xy. So what we got to do is we got to keep range the same over here, and then we just have to turn this implication into conjunction, right? And then negates the expression here. But the question asks you to also simplify, right? That's something we'll do. So it's going to be negation, which will be not, right? And then we're going to say, what about existential quantification, right? You also got a hint from the earlier question, but you should know it's a hash sum. And then we got x, comma, y. And then range will be the same. So I'm just going to copy that. X, net, also y, net. And this one will be conjunction, right? And then over here, we got to simplify that, right? So let me do that here. So we're going to do not the case x plus y larger than or equal to 10 and x plus y less than 20, right? So it's like a De Morgan, which we also spoke about in the lecture. Not P and Q is going to be not P or not Q. So it's going to be not x plus y larger than or equal to 10, or not the case that x plus y less than 20. All right. And then it's just a very basic relational property that when you say not the case, larger than or equal to, it should be equivalent to less than. Okay. So for this part here, I can just further simplify to say it's equivalent to x plus y less than 10. And this part over here is going to be x plus y larger than or equal to 20. All right. So that's an aside for calculation. So now I can put everything down. Okay, let me just move this a little bit to the left. Okay, so we're gonna have over here, let's say, because we got or over here and precedence. So for precedence of logical operator, conjunction should always come the first. All right, and then disjunction, and then implication. Negation should be the first one. That's the strongest. And then conjunction, disjunction, and then you have implication. But in this case, because we need to have OR, we want the OR to be evaluated first, right? It's part of the property here. So that's why we got to bracket it. All right. So here we're going to have x plus y less than 10. Let me just double check. Yeah. Or x plus y larger than or equal to 20. Right? Of course, don't forget, you also got some ending bracket over here to match the negation. All right. So the final answer is this one here. All right. Any question here? Okay. I hope that was also clear. Okay. I'll pause for just one moment, just in case you want to ask any follow-up. All right. If no, let's now move on. Number 5. Okay. Okay, for number 5, it's this one also is also testing some basic knowledge here. So we got two sets S and T. And what is the maximum relation basically? So R is a member of S. Okay, so R is a member of S T. And if you recall, what will be the interpretation for this one here? It will be the set of all possible.
Professor, somebody asked that question in the chat.
Yeah, let me finish this and then I'll get back. Yeah, for sure. The set of all possible. Yeah, since I already started discussing this question, why don't I finish that and I'll get back to the chat. So guys, next time, please just enter a little bit earlier so I can just monitor that before I get to the next question. But let me finish the one first. This one wouldn't take long. The set of all possible relations between S and T. All right, and then we're asking about the maximum relation, right? As we say in the class, if I ask you about minimum relation, that'll be just an empty set. But maximum is going to be the cross product, right? It's going to be S cross product T. And now we just need to be cautious about how to numerate it, right? So here I already explained the rule. If I ask you to numerate something also similar in the test, it's going to follow the same convention for the ordering. So just make sure you get used to that ordering, okay? So now it will just be this. So cross product itself is a set of order pairs. So we got X and Y. So let's go for X first. X can be mapped to 1 or 2 or 3. So X1 and also X2 and also X3, right? And then talk about Y. And Y here can be mapped to also 1, 2, and 3. So Y1, Y2, and also Y3. Right? So that will be the answer for this question here. Okay, just before I move on back to the chat, any follow-up to this? This one should be quite straightforward. Anyone? All right, so that one should be the final answer. So let me see if there's anything on the chat. Is the parenthesis after ampersand necessary? I presume you talk about the previous one here. Yes, it is necessary. So here and here, yes, it is necessary. Oh, sorry. Let me explain a bit further. So let's say this. If you say P and Q or R, the standard precedence rule is the conjunction should really bind tighter than disjunction. So if we don't have any parentheses over here, you can think about this one here is like a P. This guy here is like a P. Excuse me. This one is like a P and Q or R. Because what we really want is to evaluate the OR disjunction first. But if you only have that without the parentheses, it will be as if we try to do P and Q first or R. Because conjunction will actually bind tighter than this junction. Okay. So that's why you want to really make sure the parenthesis is added over here. Maybe you didn't know that before, but now you know the precedence. Yeah. All right. Sounds good. Okay. All right, guys. Okay. If you got any follow-up to the previous question, feel free. But I might just go back there a little bit later. Okay. All right. This one is good. I'm glad you asked. How about this one here? Okay. Any follow-up to this? If no, we got two more. Okay. All right. This one's good. Why don't we okay, let me see the chat just right before I start. Okay, nothing here. Okay. Let's now do question 6. Okay. This one we still got S&T over here. And then we got numerate the following set, and that's using set comprehension notation, right? So set comprehension, please make sure you also review it. We talk about so many examples about set comprehension, and especially when we went over all the sets and relational and functional operators, the way we specify each operator's meaning is by using set comprehension. So definitely want to make sure you can read and also write set comprehension. All right. And for this one here, why don't we just, for fun, turn that into math form? So it's basically talking about set. Every member is going to be an order pair AB, such that. So A should be a member in set S, and also B should be a member of set T. And also A should not be equal to X, and B should be less than 3. Okay. So I would say if you feel comfortable enough, you might just be able to, figure out the members on the fly. But if not, that's okay. We don't really have that many combinations. As you can see, we got AB here. A has how many possibility? Only 2. And B has only 3 possibility. Overall, we got 2 times 3, only 6 members. So I think to be very safe, why don't we try to enumerate them out first without these constraints? So we handle this one here first, and then we try to filter out certain pairs that doesn't satisfy this. That's what we'll do. All right. So what about just by considering this part over here, we got the following set of order pairs. So we got X1. Actually, that's exactly this one here, if you can see, right? That's exactly this one here. All right. Let me just write it down first. So we got X1, X2, and also X3, also Y1, Y2, Y3. Right? So this set of order pairs correspond to the first part over here. But because we got a conjunction, that means in order for each order pair to be kept in the resulting set, this constraint must be true as well. All right, let's see. So A cannot be X. So that means this and this and this. Because the first member is actually X, X equal not equal to X is false, right? In that way, it should really get rid of them. All right, so this part over here, so let's see this. So A should not be equal to X. So that means we should get rid of this, and also get rid of this. And also B should be strictly less than 3. And of course, this one here is not going to pass. Let me use a slightly different color just to show. How about this? So B should be strictly less than 3. So now you can see 3 less than 3 is false. So it's not going to satisfy. So we only got Y1 and Y2 left. So Y1 and Y2, right? So that should be in the resulting set, right? But of course, this is only a sketch. You want to write down the answer properly, right? So the answer is going to be Y1 and Y2 in that order. A set where you got Y1 and also Y2. So this question here, I would say if you see that the 2 sets I gave to you are not really that huge, especially for the combination, I would say write it down first and then consider other constraints like what I did, and then figure out what members can be filtered out, which means they don't really satisfy any of the constraint over here. All right, guys. I think you may also want to think about, well, of course, I'm just trying to show to you how you're supposed to take take the practice question there and try to make your own question. Right. So for example, for here, you can see I got conjunction over here, right? Okay, maybe this is not so interesting to play. So you can think about this is like a range constraint. And this part here is more like a property. So if I were you, I would try to maybe modify the question slightly and work out what should be in the set. So for the property here, so let's say we still keep the conjunction. Okay, conjunction, don't change it. It should be there. Okay, but why don't I say now for the property, what you can try is, what about if I change that to be A not equal to X or B less than 3? What's going to be the resulting set, right? That'll be your exercise, number 1. Also, number 2, what about A not equal to X implies B less than 3? I'm just enumerating all the possible logical operators, right? Or you can also try, for example, in another case, let's say A not equal to X or B less than 3, right? So these are 3 possible exercises you can do, all right? Alrighty. Any question here?
I have one question about the actual test. Like, is the test gonna consist of 7 questions or similar in length or?
At this point, I don't know because I'm still finalizing the questions there. But as I said, the formats will be very similar to what you're seeing here in the practice test. And I believe I said something there. So let me just double check. So give me just one moment. I'm going to share my browser.
Okay.
Yeah, it's a fair question. But at the moment, I'm still finalizing. So that's why I cannot really tell you. But I think maybe more or less around 7. But you're given more time, right? 15 minutes, not just 30.
Oh, okay. Okay.
Yes, but let me just show you something here, which I think is important, just in case you guys missed that. Let me see here. Give me just one moment. Uh, almost there. There we go. There we go. Okay. So when you first tried out the example test, you will see something like here, right? So the example question are really meant for familiarizing yourself with the format and the workflow, right? Multiple choice. You might be expected to type some answer, the ASCII syntax, but as I said, I'm not going to ask you anything that's not covered by the math lecture, right? And also not meant to cover all the topics. So maybe you want to just try to get yourself, get some study mates together just to maybe modify the question slightly to see what the answer might be. That's also a good practice. And in the actual test, it may be more. I would say not many more than 7 if there's going to be more. And question might be harder. Okay. So I think I would like to see how you may be able to solve new problems in the actual test. Okay. Good. But anything I'm going to test you on the actual tests, I always make sure it's really something that we discuss in the class. I never ask you guys anything I didn't teach. That's the principle. Okay. Anyway, so I want to show to you. But if I can give you more tips about the test, I'll try to do that maybe on Tuesday. But I'm still finalizing the question. Yeah. Anything else you want to follow up?
Yeah, I think somebody has a question in the chat
In the chat?
also.
Okay, sure. Why not? Give me just one moment. I'm going to go to the chat. Okay. What should we type as the answer? The range and property given lead to an empty set. Should it be in the form? Yeah, I think so. So the question was, okay, for example, right? Let me make this up. For example, let's say the question might be, I'll put it here, right? So let's say another question. Why don't we say A, B? Let's say A is a member of S, and also B is a member of T. Let's say let's say A, here, yeah, okay, let's say A is equal to, let's say Z, and also B is larger than 3. How about that? All right, this is also a set comprehension. So we are saying that A should be in the S and B should be in the T over here. But A cannot be Z, of course. So this can never be satisfied, right? Or even that, let's say, let's not go for that extreme. I can simply say, let's say A will be equal to X. Let me just erase it. Let's say A equal to X and B larger than 3. And this is simply not possible because in order to be in T, either 1 or 2 or 3, none of them is larger than 3. So that means the resulting set should be empty. Now, how do you type empty set? Well, that's going to be ASCII sign. So it will be just empty. So I think that what your classmate said in the chat is actually correct. That's how you type without any space. Okay. That's just one example where you can type empty set. It's possible. For example, if I ask you about the let's say minimum relation, in that case, there will also be an empty relation, right? Good. Alrighty, let's now move on. Okay, final question. Okay, let's solve this one here, and then we can still have maybe some time if you guys want to ask me anything related to math lecture. But don't forget, I still got my office hour tomorrow, Monday over Zoom, and also Tuesday in person. And since you guys will be asking about your written test, well, I'll give you guys priority for 3342. So if I got any 20, 30 students, I can let them wait. How about that? Okay, so Tuesday, if you want to ask me any question, feel free to drop by my office. Okay, okay, let's now take a look. Okay, so we want to compute this expression here. All right. All right, guys, how about test you yeah, question? Go ahead.
Just a quick question. So, just to confirm, we won't be given any rodent syntax event B form, right? In the test.
You mean when you say event before, you mean like event, like a guard or events, right? Is that what you're saying?
Oh no, not that one. The rodent syntax, the one that you know the sheet that we use to convert maths, the symbols that we're typing into the rodent
Like
format.
this one here?
Not that, Prof. Basically the rodent syntax.
Rodent.
If you're writing, yeah.
Billy, so are you talking about syntax like this, like an ASCII form? That's a rodent syntax.
Yes. So the sheet that allows us
Yeah,
to see what.
yeah, the sheet you will not be given. You will not.
Okay.
Yeah.
Okay.
So, but I would say, as I said, so you just want to make sure you understand how to do the basic ones, logical quantification and also conjunction, disjunction, anything that's covered in a math lecture. You can just make yourself like a piece of paper, just before the test and list them all. I'm not going to ask you anything that's outside the math lecture. That's something I can guarantee.
Okay. Thank you, Prof.
Good. But just a little bit look ahead. Just for the actual final exam at the end of the semester, you guys will be allowed to make data sheets for the exam. So of course, since that one's going to be 100% cumulative, so I wouldn't require you to memorize everything. In that way, you can definitely put any information you like. I'll give you a little bit more information about data sheets once we get closer to the exam. Okay.
Okay, Prof.
No problem. But for this written test, so just make sure you kind of study for what's covered in the math lecture, the math form. Right. All right, so final question here. All right, so apparently we got some relational operators. So guys, what is this? Can anybody type the exact meaning for this operator on the chat, please? I hope you guys can get it right. What is this? Anybody? Domain restriction. Well, you're getting on the right track, but don't forget, domain restriction will be something like this. But this one here has this, right? Subtraction. Okay, maybe that's what you meant. Just be careful, this will be domain restriction. And this will be domain subtraction. All right. And you can also see the contrast over here, right? You can see one guy here got one more, and this one here only got one, right? But this one will be range. It's pointing to a different direction. So this one over here is really domain. Okay, let me write it down. So this one here is the domain restriction. And this one over here is the range. Sorry, domain subtraction. That's really what I meant to say. Subtraction. What I'm talking about here. Subtraction. And this one over here will be the range restriction. All right. And that's not computed. Let me write it down elsewhere. So it's going to be X domain restrict. Well, that will be the math form, right? So that will be over here. We're going to compute something first. And you don't really need to worry about what if the relational operator has no parentheses, in which case, which one should we evaluate first? I'll make sure I give you parentheses. I don't think the order of evaluation without any parentheses should be the focus. So I'll always give you parentheses, okay? All right, so now we got R, range, oh, it's domain, subtraction, right? That's really what it corresponds to. And then R, range, restricted to another set, which would be T, set minus 2. All right, that's what we have. And we can definitely calculate this one here first. This will be some set difference. So what's a set difference between T and also a singleton set 2? Well, get rid of 2 from there, right? So that'll be just 1, 3. All right, and then let me put R over here just for us. So R is actually here. R is x1, x3, y1, and y2. All right, let's now do that. Okay, so now what about the first range restriction? We want to keep all the range. We want to keep all the order pairs where the range is either 1 or 3. So this one should be kept. This one should be kept. This one should be kept as well. So this one should be gone because the range over here is not either 1 or 3. All right. That's basically what happened after this. So now after this particular evaluation here, we got basically another relation, which will be x1, x3, and also y1. And then we got something called domain subtraction. So this is so important because if you understood this guy here as domain restriction, you will just get a question the opposite way, which will be wrong, right? So that's subtraction. We want to subtract all the pairs where the domain value is simply x. So you can see the domain value is x here and x over here. So they should be removed from the resulting set, right? So the final answer should be just y1. So that should be the final answer. All right. All right, guys, any follow-up to this? And of course, what you can try, again, you can just try to maybe make some modify the question slightly. I can put it here. What about I change this one to be, let's say x, rather than domain subtraction, maybe domain restriction. And then over here, I can say R, range subtraction. And then T, set difference, maybe 2 over here. All right, that could be some exercise you can do. Yeah. All right, so I think that's about the practice question there. If you haven't really tried them out, you can maybe that's fine. Maybe after you have gone through all the relevant materials, maybe you can try them out again. You can submit the attempt for as many times as you like before the test. And do you guys have any questions related to the math lecture you want me to go through? I can spend a little bit longer with you if you want to.
Professor, I had a question.
Yes.
So when do we use the choose, like, yeah, when do we use the choose operator, basically? I had some questions regarding.
the choose operator, you mean are you talking about like a X, like a set over here?
Yes.
Okay. So the choose operator is usually for non-deterministic assignments. It's for the events basically. So this is like a non-deterministic assignments.
Oh, I meant in that in the math lecture, Prof.
In the math
The one
lecture.
that we used in the power set.
Oh, sorry. I got it completely. Okay, I was thinking about something else. I beg your pardon. That's okay. Now I know what you mean. Yeah, basically talking about this one here, right?
Yes.
Okay. So what's your question again? Like when do you use it?
Yes.
Okay, good. So I would say the place to use it is really to say, okay, so let's say this. Of course, we talk about what it really means when you got n. So this is like given n elements, how many ways can we make subsets of size n? So this is really what it means mathematically, right? So we talk about how also how you can derive the formula a little bit. So you can also review that part. But I think the the most common use in our context would be, let's say, for example, if I say I want you to compute, let's say the power set of, let's say, 1, 2, 3, 4, 5, 6, for example. If there's something I want you to compute, right? Let me write it down maybe on a different page. So let me better. So for example, I might say, now I want you to compute, let's say the power set of 1, 2, 3, 4, 5, and 6. Right? And we said that the whole thing is going to be a very big set over here. And we know that the minimum subset should be just empty set. And that one there is really a subset of size 0. And the maximum subset will be just the set itself. 1, 2, 3, 4, 5, and 6. So that will be a subset of size 6. Okay, we should really try to enumerate also things in between. Okay, for example, what about the subsets of size, let's say 3, right? Before you try to enumerate them out, it would be useful to actually know how many are there, right? So now you can see we got 6 elements over here. 1, 2, 3, 4, 5, 6. Now I want to make, excuse me, I want to make a subset of size 3 out of it, right? So it's going to be 6 times 5 times 4 divided by 3 factorial. And I know this can cancel out. It's going to be 20, right? Of course, if you really have to enumerate them out, there should be 20 of them over here. But I might ask you maybe different question. I might just ask you how many subsets are there that are in the power set. Let me write it down for you. So how about this, for example? Let's say I want to get a cardinality of some set such that S is a member of the power set of 1, 2, 3, 4, 5, 6. Okay, this will be a nice example here. Thank you, Billy. So let's now complete this. And then, all right, I'm going to say here, the cardinality of S equals 3 or the cardinality of S is equal to, let's say, 5. All right. Let me just make sure I bracket that correctly. Okay, that's good. All right. Basically, I'm saying get all the subsets that's in the power set, right? And then the subset should be included in the final set as long as the cardinality of it should be either 3 or 5. And of course, one way to do it will be the brute force. You have to numerate out all the subsets from here that's of cardinality 3 or 5. But you can also use the choose operator, like over here, right? So now to really compute it, the whole thing over here would just be equal to, now I got 6 elements there. 1, 2, 3, 4, 5, 6. Now I want to make a subset of size 3. Because it's OR, so I should really add the other possibility. And also 6, choose 5. And this one we already know is going to be 20, and plus 6, choose 5. And some property which we also mentioned in the lecture. So 6 choose 5 will just be the same as 6 choose 1, right? Which will be just 6. All right. 26. Yeah, so Billy, I would say this might be the most common use to really figure out, given a set of elements, you want to make certain subsets from there of certain size. That's how you use a choose operator. But I would say don't be too restricted by that context only. You should also understand what this choose operator really means mathematically. So if I tweak the problem slightly, you will still be able to apply it.
Right. And when we're calculating the cardinality of a power set, so that includes all the subsets
That's
of
correct.
all the.
That's correct.
Okay.
That's correct.
Okay.
So I remember, yeah, I think that's a good point. So let me just, for the sake of completeness, so let me just show you one thing here. I can find it very quickly. So if you remember, I think in one of our review lecture, let me just get that very quickly. This might be the one. Okay. So I think in one of the notes there, we had some result over here. There we go. So the one we talk about is 2 to the power of, right? The cardinality of the set, like a 2 to the power of 5, the one we did in the earlier practice question. That one there can be proved, could be shown to be equal to all the subsets of size 0, or the subsets of size 1, etc. This can be proved, but we don't need to worry about the proof. You can just know that's the result.
Okay. Thank you, bro.
Okay, you're welcome. All right, guys. Anything else you would like to ask? Yeah, I would say keep studying for the written test one. You can definitely try to practice the practice question here, but I would say the more important thing is to make sure you go over all the cover materials that's actually specified in the written test one guide. If there's any more hints I can give you guys once I finalize the question, hopefully by Tuesday's class, I will definitely mention them in the lecture. Okay. But I would say you definitely want to make sure you go over all the materials. All right, that's important. Right. All right. If no further question, just to remind you, I still got my office hour tomorrow and Tuesday. So I will give you guys priority. But for the Zoom, it may not be that easy for me to tell you're from 3342. But if you come on Tuesday, just signal to me you're from 3342. I'll give you priority. All right. All right, guys. Thank you so much for coming. And if no question there, and then I'll see you maybe on Tuesday in the class, right? Enjoy the rest of your Sunday.
All right, you too. Bye.
Bye-bye. Take care.